Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter called as identities from trigo ratio. Let's see this. Prove that square root of 1 minus sine theta upon 1 plus sine theta is equal to sec theta minus tan theta. Right? Let's see this. Now, write LHS. Left hand side is square root of 1 minus sine theta upon 1 plus sine theta. Now, in order to get rid of the square root sign, what you will do is you will rationalize the denominator. Guys, anything you don't follow, please ask me. Rationalize denominator. How do I rationalize the denominator? I'll write the same thing first, 1 minus sine theta upon 1 plus sine theta and multiply the denominator with the conjugate, that is 1 minus sine theta, 1 minus sine theta. This will give me square root of 1 minus sine theta the whole square. 1 minus sine theta, 1 plus sine theta is nothing but 1 minus sine square theta, right? 1 minus sine square theta can be written as cos square theta. So this is 1 minus sine theta the whole square upon cos square theta, right? This can be written as square root of 1 minus sine theta upon cos theta the whole square. Square and root gets cancelled, so this will be 1 minus sine theta upon cos theta. This is going to be 1 upon cos theta minus sine theta upon cos theta. 1 upon cos theta is sec theta, sine upon cos is tan theta, and that's what you have to do. Right? Let's see the second sum, guys. You have to prove, guys, please pay attention. Anything you don't follow, please ask me. You have to prove that cosec x plus cot x upon cosec x minus cot x is equal to 1 plus 2 cosec x cot x plus 2 cot square x. Right? This is what you have to prove. Let's see this. Now, let's start with LHS. LHS is cosec x plus cot x upon cosec x minus cot x. Right? Whenever you have a fraction, in order to get rid of the fraction, you multiply the denominator by its conjugate. So if I multiply the denominator by conjugate, this will be cosec x plus cot x upon cosec x minus cot x, multiply by conjugate. Cosec x plus cot x, I am multiplying by the conjugate of the denominator. That means the same denominator with center sign reverse, complementary center sign. Cosec x plus cot x. So my numerator becomes cosec x plus cot x into cosec x plus cot x, that is cosec x plus cot x the whole square. The denominator is in the form a minus b, a plus b, which will be a square minus b square. Right? Now we know the identity, guys. See this, I'll write this in different color. We know that cosec square theta is equal to 1 plus cot square theta. Right? We know this identity. Now in this, if I take cot on the other side, that means cosec square theta minus cot square theta will be 1. That means here the denominator can be substituted as 1. The numerator is in the form a plus b the whole square, which will be a square plus 2ab plus b square. And the denominator, if I use the identity, becomes 1. Now, substitute the terms that you don't need, right? Cosec square x, by using this identity, can be written as 1 plus cot square x plus 2 cosec x cot x plus cot square x. This is 1 plus 2 cosec x cot x plus cot square x plus cot square x is 2 cot square x. So that is your RHS, right? Move on to the next sum, guys. Prove that cosec 6 theta or cosec 6a minus cot 6a is equal to 1 plus 3 cot square a plus 3 cot 4a. Fine. Now let's see the LHS. LHS is cosec 6a minus cot 6a. Cosec 6 can be written as cosec square a the whole cube. Cosec 6 can be written as cosec square a the whole cube. 3 2s are 6. Similarly, cot 6 can be written as cot square a the whole cube. Right? I could use the identity, guys. I could use the formula, algebraic formula a cube minus b cube. A cube minus b cube is a minus b the whole cube plus 3ab a minus b. Right? So if I use this formula, guys, I'm going to use this formula. If I use this formula, this is your a and this is b. So this is going to be a minus b, that is cosec square a minus cot square a plus 3 cosec square a cot square a into cosec square a minus cot square a. But cosec square theta is 1 plus cot square theta. Guys, cosec square theta is 1 plus cot square theta. Therefore, cosec square theta minus cot square theta should be 1. Right? Cosec square theta is 1 plus cot square theta. If I take cot on the other side, that means cosec square theta minus cot square theta should be 1. Right? So here, cosec square a minus cot square a can be written as 1 plus 3 cosec square a cot square a into 1. Cosec square a minus cot square a is 1. Now, this is 1 plus 3. Cosec square a can be written by identities as 1 plus cot square a into cot square a. This is 1 plus 3 cot square a multiplied by 1 will give you 3 cot square a. 3 cot square a multiplied by this cot square a will give you 3 cot 4a. I presume that's my RHS. That's how you prove that LHS is equal to RHS. Next, let's see the next sum, guys. Prove that sin raised to 8 theta minus cos raised to 8 theta is equal to 2 sin square theta minus 1 into 1 minus 2 sin square theta cos square theta. Right? Let's see how do we do this. Now, this can be written as LHS is sin raised to 8 theta minus cos raised to 8 theta. This can be written as sin raised to 4 theta the whole square minus cos raised to 4 theta the whole square. This is in the form a square minus b square. Guys, first thing I did was I split the 8 as 4 into 2. Now this can be written in the form a square minus b square. A square minus b square is a plus b into a minus b. Right? Now, sin 4 theta can be written as sin square theta the whole square plus cos 4 theta can be written as cos square theta the whole square. 4 I'm splitting as 2 into 2. Similarly, here also this can be written as sin square theta the whole square minus cos square theta the whole square. right? Here I can use the formula a square plus b square, guys. Formula a square plus b square is nothing but a plus b the whole square minus 2ab. That's a quadratic equation formula. A square plus b square is a plus b the whole square minus 2ab. Assume this number to be a, assume this number to be b. That means this is in the form a square plus b square. So that is going to be a plus b the whole square minus 2ab. That is going to be the expansion of my first bracket. Second bracket into. This is in the form a square minus b square. So this will be a plus b into a minus b. Fine. Now, sin square theta plus cos square theta is 1. So this is 1 square plus minus 2 sin square theta cos square theta. That will be my first bracket. Into second bracket, sin square theta plus cos square theta is 1 into sin square theta minus cos square theta. Right? Now go on substituting whatever you don't want. Right? This can be written as 1 minus 2 sin square theta cos square theta can be written as 1 minus sin square theta cos square theta. Sin square theta plus cos square theta is 1. So cos square theta can be written as 1 minus sin square theta into. Here again you wanted that 1 minus 2 sin square theta cos square theta. I should not have substituted that. I want this in the answer, and here I want a difference. So I have 1 minus 2 sin square theta cos square theta. I leave it as it is because I want that in the answer. You substitute what you don't want in the answer. The second bracket is sin square theta minus cos square theta can be written as 1 minus sin square theta. So this will give you 1 minus 2 sin square theta cos square theta. Open the bracket. This will be sin square theta minus 1 minus into minus plus sin square theta. So this will give you 1 minus 2 sin square theta cos square theta into sin square theta plus sin square theta is 2 sin square theta minus 1, and I presume that's what I have to do. 2 sin square theta minus 1 into 1 minus 2 sin square theta cos square theta. That's my RHS. Right? Let's see another theorem, guys. Prove that 1 minus tan 4 theta is equal to 2 sec square theta minus sec 4 theta. Right? Now, let's see how do we do this. LHS is 1 minus tan 4 theta. Guys, please pay attention. 1 minus tan 4 theta can be written as 1 minus tan square theta the whole square. Tan 4 I am splitting as tan square the whole square. 1 can be written as 1 square. This is in the form a square minus b square. A square minus b square is a plus b into a minus b. 1 plus tan square theta by identity is equal to sec square theta. 1 plus tan square theta by identity is sec square theta into 1 minus sec square theta is 1 plus tan square theta. Guys, I'll write the identity down. Guys, I'm writing it in different color. We know that sec square theta is equal to 1 plus tan square theta formula. Now, if I take the 1 on the other side, I can say that sec square theta minus 1 will be tan square theta. So what I'm going to do is I'm going to substitute tan square theta as sec square theta minus 1. So in which case I will get sec square theta 1 minus sec square theta, minus into minus plus 1, minus into minus gives you plus 1. So this is going to be sec square theta 1 plus 1, 2 minus sec square theta. So this is 2 sec square theta minus sec 4 theta. Right? That finishes that sum. Let's move on to the next sum, guys. Prove that cosec 4 alpha 1 minus cos 4 alpha minus 2 cot square alpha is 1. Right? Let's see this. Let's start with LHS. LHS cosec 4 alpha 1 minus cos 4 alpha minus 2 cot square alpha. Now cosec 4 alpha can be written as 1 upon sin 4 alpha. 1 minus cos 4 alpha, guys, can be written as 1 minus cos square alpha the whole square minus 2 cot square alpha. 1 minus cos square alpha the whole square. 1 can be written as 1 square. This is in the form a square minus b square. A square minus b square is a plus b into a minus b. So this is 1 upon sin 4 alpha. This is going to be a plus b into a minus b minus 2 cot square alpha. This is nothing but 1 upon sin 4 alpha 1 plus cos square alpha. 1 minus cos square alpha is nothing but sin square alpha. 1 minus cos square alpha is nothing but sin square alpha upon 2 cot square alpha. Sin square alpha and sin 4 alpha gets cancelled to give you sin square alpha in the denominator. So then this becomes 1 plus cos square alpha upon sin square alpha minus 2 cot square alpha can be written as cos square alpha upon sin square alpha. Now sin square alpha can be taken as the common denominator. If I take sin square alpha as a common denominator, this will become 1 plus cos square alpha minus 2 cos square alpha. This is 1 plus cos square alpha minus 2 cos square alpha will give you minus cos square alpha upon sin square alpha. 1 minus cos square alpha is nothing but sin square alpha upon sin square alpha, which is 1, which is my RHS. That's what I have to prove. Right? Let's see another sum, guys. Please pay attention, guys. You have to prove that sec A minus tan A plus 1 into sec A plus tan A minus 1, sec A plus tan A minus 1 is equal to 2 tan A. Right? Let's see this. LHS sec A minus tan A plus 1 into sec A plus tan A minus 1. That's my LHS. Now, guys, I could rearrange this. If I rearrange this, this can be written as sec A. Between these two terms, I could take minus sign common. If I take minus sign common, I will get tan A minus 1. Guys, see this, minus into minus plus. That plus I am splitting as minus into minus. And this can be written as sec A plus tan A minus 1. Right? Sec A can be written as A, and this tan A minus 1 is B. This is in the form A minus B, A plus B. A minus B, A plus B is nothing but A square minus B square. Right? Now, this can be written as sec square A minus. This is in the form A minus B the whole square. So this is A square minus 2AB plus B square. Open the bracket. If I open the bracket, this will be sec square A. Yeah, problem. Sec square A minus tan square A, minus into minus plus 2 tan A, minus into plus minus 1. Sec square A is nothing but 1 plus tan square A. So sec square A minus tan square A is nothing but 1. Sec square theta is 1 plus tan square theta. Therefore, sec square theta minus tan square theta will be 1 plus 2 tan A minus 1 plus 1 minus 1 gets cancelled. Answer is 2 tan A, and I presume that's what you have to prove, RHS. Right? Let's see another sum, guys. Right, can you see another sum, please? Prove that sin x into 1 plus tan x plus cos x into 1 plus cot x is equal to sec x plus sec x. Right, I sum. Let's see how do we do this. LHS sin x 1 plus tan x plus cos x 1 plus cot x. Guys, can you please pay attention? This can be written as sin x 1 plus tan x can be written as sin x upon cos x plus cos x 1 plus cot x. Cot x can be written as cos x upon sin x. Right? I just substituted tan as sin upon cos and cot as cos upon sin. Basic formula, guys. Open the bracket. When I open the bracket, sin x into 1 is sin x. Sin x into sin x is sin square x upon cos x. Cos x into 1 is cos x. Cos x into cos x is cos square x upon sin x. Right? Rearrange the terms. If I rearrange the terms, this will become sin x plus cos x plus sin square x upon cos x plus cos square x upon sin x. Right? This can be written as sin x plus cos x plus, between these two terms I could take LCM. If I take LCM, my common denominator will become cos x into sin x. If I take LCM, my common denominator will become cos x into sin x. That means I need to multiply this denominator by sin x. Hence I will multiply the numerator also by sin x, where I will get sin cube x. Similarly, this denominator, the second denominator, I need to multiply by cos x. So I will multiply the numerator also by cos x. That will give me cos cube x. Fine. This can be written as sin x plus cos x. Common denominator is cos x sin x. A cube plus b cube is nothing but a plus b the whole cube, that is sin x plus cos x. No, I'm going to use the formula a cube plus b cube is a plus b, a square minus ab plus b square. I'm using the formula, guys. A cube plus b cube is a plus b into a square minus ab plus b square. Fine, do we get this thing here? Now, between this term, that's your first term, and the second term, I could take sin x plus cos x common. Between the first two terms, I could take sin x plus cos x common. In which case, since this whole term has come common out, instead of sin x plus cos x, only one will remain here. Plus, this term sin x plus cos x has come out. So what will remain there will be sin square x minus sin x cos x plus cos square x upon cos x sin x. Right? Now, this can be written as sin x plus cos x into 1 plus sin square x plus cos square x. Sin square theta plus cos square theta is 1. So this is 1 minus sin x cos x upon cos x sin x. Right? This can be written as sin x plus cos x. LCM, this is sin x cos x plus 1 minus sin x cos x upon sin x cos x. Whether it is cos x sin x or sin x cos x, it's the same thing. A into B or B into A, it's the same thing. Plus sin x cos x minus sin x cos x gets cancelled. So this will give you sin x plus cos x into 1 upon sin x cos x. This can be written as sin x plus cos x upon sin x cos x. Split the numerator. If I split the numerator, this will become sin x upon sin x cos x plus cos x upon sin x cos x. With the first numerator I get the denominator, with the second numerator I get the denominator. Sin x and sin x gets cancelled. Cos x and cos x gets cancelled. That leaves me with 1 upon cos x plus 1 upon sin x, but 1 upon cos is nothing but sec x, 1 upon sin is nothing but cosec x, and that's what you have to do. RHS, that's my RHS. Right? Let's move on to the next one, guys. Now, let's see something interesting. Prove that tan theta upon sec theta plus 1 plus sec theta plus 1 upon tan theta is 2 cosec theta. Right? Now, in this, what you see is that you have fraction, and the trigo ratios that are used here are complementary trigo ratios. These are those trigo ratios which are used for identities. Right? Now, let's see the LHS. LHS can be written as tan theta upon sec theta plus 1 plus sec theta plus 1. Yes. Upon tan theta. Let's take LCM. If I take LCM, this will become tan square theta plus sec theta plus 1 the whole square upon sec theta plus 1 into tan theta. Fine, do we get this thing here? I've just taken LCM. Cross multiply, straight multiply. Now we have the identity that sec square theta is 1 plus tan square theta. Therefore, tan square theta can be written as sec square theta minus 1 plus sec theta plus 1 the whole square upon sec theta plus 1 into tan theta. This is in the form sec square theta minus 1 is in the form 1 can be written as 1 square. This is in the form a square minus b square. This can be written as a plus b into a minus b plus sec theta plus 1 the whole square upon sec theta plus 1 into tan theta. Now, between the first and the second term, I could take sec theta plus 1 common. So, if I take sec theta plus 1 common, I will be left with sec theta minus 1 plus sec theta plus 1 square. 1 sec theta plus 1 has gone common outside upon sec theta plus 1 into tan theta. Sec theta plus 1 in the numerator and denominator cancels, right? Let's simplify this. This can be written as sec theta minus 1, open the bracket, sec theta minus 1 plus sec theta plus 1 upon tan theta. Minus 1 plus 1 gets cancelled. This is 2 sec theta upon tan theta, right? Sec theta can be written as 1 upon cos theta. So this is 2 into 1 upon cos theta upon tan theta can be written as sin theta upon cos theta. Cos theta gets cancelled. So this will become 2 upon sin theta. But 2 upon sin theta can be written as 2 cosec theta. And I presume that's what you have to prove, yes? That's my RHS. Fine? Let's see if we can do one more sum. Do we have the space to do one more sum? Yes. Let's see another sum. I'll do the 10th sum here. Prove that 1 upon cosec alpha minus cot alpha minus 1 upon sin alpha is equal to 1 upon sin alpha minus 1 upon cosec alpha plus cot alpha. I have to prove this. Let's see how do we do this sum, guys. Now instead of proving this, I am going to modify the question here. Guys, this same question, pay attention, this same question can be modified this way. This minus 1 upon cosec theta plus cos theta can be taken on the other side. So I'll get 1 upon cosec alpha minus cot alpha. Minus comes here, becomes plus cosec alpha plus cot alpha is 1 upon sin alpha. This minus 1 upon sin alpha goes on the other side, becomes plus 1 upon sin alpha, right? If I modify the question, I end up with 1 upon cosec alpha minus cot alpha plus 1 upon cosec alpha plus cot alpha is 1 plus 1, 2 upon sin alpha. This is what I have to prove. So whether I prove this or I prove this, it is going to be the same thing. It's just that the question has been modified. Now let us start with LHS. LHS is 1 upon cosec alpha minus cot alpha plus 1 upon cosec alpha plus cot alpha. Take LCM. So this will become cosec alpha plus cot alpha plus cosec alpha minus cot alpha upon cosec alpha minus cot alpha into cosec alpha plus cot alpha, right? Minus plus cot alpha minus cot alpha gets cancelled. This is going to be cosec alpha plus cosec alpha is 2 cosec alpha. The denominator is in the form a minus b, a plus b. That is going to be a square minus b square. That is cosec square alpha minus cot square alpha. Cosec square theta is 1 plus cot square theta. Therefore, cosec square theta minus cot square theta will be 1. So this is 2 cosec alpha upon 1. But cosec alpha is nothing but 1 upon sin alpha. So this will become 2 upon sin alpha, which is my RHS. Right? And that's exactly what we have to prove. We'll stop here for the day. Thank you very much.